Hey, good morning, everyone. I hope you are doing all right. And if your surrounding allows, please turn on your videos. So last week, we learned mostly vocabularies used in describing physics, motion in physics, to be more specific. So those quantities were position, and we represent that by a line with an arrow. It's a vector quantity. Length is proportional to value. Longer it is, larger the value. Okay. And another is displacement, which is change in position. And by the way, we denote position by x, and displacement is change in position, and we denote that by change in position, which is final minus initial. And again, we draw that as an arrow, all vectors. Remember, in physics, all vectors are represented by a line with an arrow. But this one starts from initial position. Xi, initial position, to from Xi and ends at Xf. Okay. And basically, this is, you can think of this as a displacement between first and second point, and this is displacement between second and third point, and so on. And since the velocity, or average velocity more accurately, is displacement divided by time interval, and for motion diagrams, time interval is constant. We keep it constant. Whatever it is, we keep it same for each interval. That's what time interval constant means. So that means this velocities and displacement, they are proportional, means we can represent them by using the same arrow. So depending on what we like, that arrow may be treated as velocity vector or a displacement vector. And we represent these by drawing what we call motion diagram, right? And then we also learn that average velocity, not average velocity, I mean average acceleration. So that's why my hand was hesitating to write things, okay? And so change in velocity over time interval. So that means we need to find change between, let's say, these two or these two, and divide that by time interval. So time interval is same. So this formula gives you value of the acceleration. How about direction of the acceleration? So that's where we are starting today, from direction of acceleration from motion diagram. Okay, so this is a motion diagram. So average acceleration is change in velocity divided by time interval. It is fixed, and it means here change in time or time interval is fixed, and scalar means it does not have direction. That means direction of acceleration is same as direction of change in velocity. Not the direction of velocity, but change in velocity. So probably if you took science class in school or something like that, you may have learned like v is x over t and a is v over t. What happens is this definition is not always correct. Okay, what is correct definition? It's change in position over time and change in velocity over time. So it should be that change, not the velocity at a point. Okay, so we need to keep that in mind. So we need change direction of change in velocity, which is not, which may or may not be same as direction of velocity. Which velocity, initial or final, right? So here initial means later, I mean previous, and final means later. So we can choose any two, okay? Either 1 and 2 or 2 and 3 and so on. So we are learning to draw how to, we are learning how to draw change in velocity vector. And why is that important? Because direction of change in velocity vector is same as direction of acceleration. So that tells us the direction of acceleration. Okay, so that's why it is important. So how do we do that? I like to call it tail to tail and then tip to tip in short. But we have to be careful here. Tip of previous means initial to tip of final, let's say. Later means final. And remember, whichever two we decide, one gonna be initial, previous one gonna be initial, and the next one gonna be final. So here, so you want to first, in the note I have written 3 steps, but here I am just writing 2 steps. So first you need to decide which one you like to use. Okay. Are you using V3 and V4, for example, or V2 and V3? You want to choose 2 consecutive from drawn velocities. Okay. So draw 2 consecutive arrows by lining up their tails. Okay. So for example, here I am choosing V2 and V3. Oh, V1 and V2. Okay. So pay attention. In this case, V1 is longer than V2. It does not have to be super accurate, but make sure you are keeping track of which one is shorter and which one is longer. That is very important because that's what determines the direction of the acceleration. Okay. So ideally, I would be drawing on top of each other. Okay. But what happens if I do that? Then one may be invisible. So that's why I'm drawing on the side so that we can see both of them. But ideally, it would be, like drawing like one on top of another one. Okay. So that is one step. And the last step is to actually draw that change. So here what I did was I put the tails together. Okay. Although B1's tail was there, I brought B1 here, and then I brought V2 over here, and I drew them by lining up tails together. Okay. So now, once we have done that, so this is the step where we are drawing change in velocity vector, which gives us the direction of acceleration. Okay. So how do we do that? It says draw velocity change or change in velocity vector from tip of previous to tip of later. So previous means initial and later means final, right? So if you like, you can write this as a final and this as a initial. So tip of this one is here, initial is over there, right? Somewhere in this line, and tip of final is there. So we need a line that starts from tip of BI and goes like that. And you may be thinking, okay, why is not going something like that? Remember, ideally we draw one on top of each other. They are sideways just to make them visible. So that's why we draw like that, okay? We simply draw straight like this because both of them are in the same direction. So they could be right on top of each other. Tails could be touching, right? If the tails were touching, then what would happen? The other one would be somewhere here, and this is going to be that. Okay, I think I have drawn that on the slide. So that is the change in velocity vector, and that is the direction of acceleration. And by the way, change means final minus initial. So what are we doing? We are subtracting initial from final. We are subtracting two vector. Subtracting so since vector has a direction, what happens is it does not work like a regular number like scalars. So for example, if I were to subtract 3 and 4, I may get maybe 5. That's possible. So that's why following this rule is important. Okay. So whenever you see vector quantities like position, displacement, velocity, acceleration, be careful about direction. Pay attention to the direction as well. Okay. So that's how we draw it. Easy, right? Shut your eyes and do you recall these two steps? Can you recall it by shutting your eyes without looking at here? These two steps. In short, I'll say, okay, just like I have written here, tails together first, and then from tip of previous to later, or tip of initial to tip of final. Two steps. Tails together, first step. Last step, from tip of initial to tip of final. From tip of which? Can you type that on the chat? From tip of which? Oh, maybe everyone is not available here. I have to set that up. Now it should work. So when you are drawing change, you draw from tip of which one? Tip of previous or initial. Okay. So don't forget. So I see a lot of you are not writing. Okay. Hopefully you at least remember. Okay. So how do we know? Let's try drawing it, right? So here is question for you. So I'm starting clicker now. So do you have paper, pencil, or something you can draw on? So make sure you keep that inside, okay? For each and every class. Here comes the question. And you have 2 minutes. So make sure you draw them, okay, using two methods. Tails together, and from tips of which one? Tip of which one to which? Remember that. Draw them. Draw them. So you can think of this as the initial, this as a final, because 2 is later than 1. Okay, 30 more seconds. If you did not draw, make sure to draw it. Yeah, so if something happens to your app, look at the screen. I'm displaying screen. So Nicholas is saying, okay, picture is messed up on the app. So 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see how did we do. Oh, we have A and B competing. What happened? It was just 2 steps. Why is so difficult? So what does that tell us? We need practice, right? We need practice. So did you draw it? Ask yourself. Did I draw it or did I just choose it? Okay. So I don't know the answer, but I know how to draw it. So tails together, what I need to pay attention to? Now final is longer. So initial is shorter and final is longer. BF is longer than BI. So that's how it is. Okay. So I drew with tails together. And now last step is to draw change. So change we draw from tip of which one? So that's why I ask you to type from tip of BI. So that's why it goes in that direction. Okay. So in this case, looks like A is correct answer. Interesting. I was counting how many of you responded on that one, on the initial thingy I asked you to, and 20 of you responded on the Zoom. That's what I was doing when you guys were polling. Okay. And then turns out 21 of you did it correctly. I don't know, that is their one-to-one correspondence. At least that tells me at least 20 students were paying attention. Okay. Most likely they knew what to do or how to do. So anyway, it's not scientific way of, uh, you know, uh, let's say coming to the conclusion, but some idea. So now, what did we saw? So in previous slide, so in this case, acceleration is in same direction. So that means the direction of acceleration as well. Okay. So what's happening here? Final is longer than initial, means final is larger. Final velocity is larger than initial velocity, means velocity is increasing. So when velocity is increasing, acceleration is in same direction. So now I'm going to go back to previous slide and see what we had here. Okay. Over here, what was happening? The lengths were getting shorter means velocity was decreasing. So when velocity was decreasing, the direction of acceleration was opposite. Do you see that? Do you see that? So when velocity is decreasing, acceleration is in what direction? Same or opposite? Opposite direction. So I wrote this for the, increasing, but you can rewrite and make this increasing, decreasing. Let's say DECREASING. Oh, I don't have room here. Decreasing, and then the same becomes opposite. So we proved it by actually drawing. Okay, we proved it. So in this case, object is moving in either in the same direction, slowing down, speeding up. Sometimes object may turn around. Okay, so what happens is that object may change the direction. So you may be going that way and somehow you decide to return. What happened? Your velocity changed. Whenever velocity changes, that means you accelerated. Okay. So in that case, how do you find direction of acceleration? When you reverse the direction, for example, how do you find it? Same method. So same method. And here is a question for you. So I'll give you some hint here. So it has numbers as well. It says east, oh, east and 12 meter per second. Okay. So that is value and that is direction. Let's say east is to the right. Let's put compass, and that way I can draw initial velocity vector. Vi is this direction. And how about final? Reverses direction and heads west at 16 meter per second. So that means it's reversing direction, means it's going that way. So Vf is 16 meter per second. And remember, here these are just values, 12 meter per second, 16 meter per second. Those are just values. How about direction? The arrows, line with the arrows gives you the direction. Okay. So now I did that. So you need to find, see, the acceleration is change in velocity, and we just learned how to draw a change in velocity vector, right? So go ahead, draw it. And since you know the length of this one and that one, you should be able to find the length of delta V and use that and time interval to compute the acceleration. Okay. So you have 1 minute, maybe 2 minutes. Okay. 2 minutes for this. So do not use your gut feeling. Use the method you learn. If you use your gut feeling, most likely you may be wrong. So that's why we went through so much time learning this. 30 more seconds. Tails together, and from tip of initial to tip of final. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see how did we do. Oh, we have problem. We have problem. Let's see what happened. So we drew VI and BF. So how do I draw tails together? So VI is going to the right and BF is going to the left. So this is VI, this is BF. So tails together, so that's how we draw. Remember, we cannot change the direction. So one is going left, another one is going right. So that's the way to draw tails together, okay? In this case, they are lined up along a line because there is no overlap. So now that's step one. So what's the last step where we draw and goes to tip of final, okay? So that is delta V. So what's the length of this? See, it starts from here and it goes all the way here. So from here to here, we know length is 12 meters and here 16. So all the way from here, tip of initial to tip of final, it is 28, 16 plus 12. And unit is meters per second because unit of velocity and change in velocity, they're going to be same. Now the acceleration, what do? You just divide that 28 meters per second by 4 seconds, and that gives us 7 meters per second square. So that is the value, and direction we already drew, so it is west. Okay, looks like D is correct answer in this case. So B, so second most popular choice was B, and direction is west, so that's great. So you figured out at least direction, okay? So there is a question, why is it meter over second square? See, this is now acceleration. Change in velocity has meter over second, and time has a second. So meter over second times 1 over second gives you meter over second square. So there was a question on the chat. So when you write this kind of question, please write, to everyone so that everyone can see the question. Choose everyone from the drop down and then write your message. Okay, so that's that. But in this case, we have numbers. We should be able to figure out just by using number, even without drawing it, okay? We should be able to. How do we do that? So let's take a look, okay? So let's take a look. So what we have is value and direction. So now what I'm planning to do is I want to use this formula. Change means final minus initial and divide that by time interval. So now I want to put that velocities in formula, this formula to calculate acceleration, let's say. Can I put east, west in the formula? So what do I do to represent physical direction in the formula? What do we do?
With the sign, like positive and negative.
Exactly. Great. So what we have to do is now, when we don't have this arrow, we need to modify how do we write VI. So in this case, first we need to assume a positive. Which one we like to choose positive? Let's say east is positive. So in this drawing over there on the top, now I'm adding positive sign there. So that says, okay, east is positive. Okay. So now what happens is now this VI is positive 12 meter per second. Now VF is pointing to the west. So when we choose east as a positive, west must be negative, right? So now when I use those numbers in this formula, what happens? VF is negative 16 meter per second. And then there is negative sign in the formula, right? And we have a positive sign, not negative sign. So positive sign for 12 meter per second. So this negative times positive is just a negative, and time interval in this case is 4 seconds. Okay. So 16 and 12, both of them are negative, means they gets added. Okay. So it becomes negative 28 meter per second over 4 seconds. That gives you negative 7 meter over second squared. And what does this negative sign means? Since positive is east, negative must be west. Exactly. Okay. So that is west. See, either way, we are getting same answer as it should be. How we do it shouldn't affect the answer. Final answer, physics is always same. Okay. The method may be different. As long as we are following the correct method, we should be able to do it. So when there are numbers, you may be able to find, acceleration from without drawing it, but there may be question where there may not be a number. So even if there are numbers, sometimes it may be difficult. So I have another example here. Next. And by the way, did I choose the correct answer? Yes, I did. So we may have something like this. So there are no numbers. Even if there were number, you could not just use that VI and VF. In this case, you have to draw it. Okay, you have to draw it. So we can think of, see, it says initial means we can say, okay, this is VI and this is VF. It says north, that's a compass, right? So that means this is east. When up is north, right is east. So that's how the compass works, right? So now go ahead, draw BI and BF with tails together and draw a change in velocity vector, okay? So again, you have 2 minutes. Okay, 30. Oh, I think I said 2 minutes. So, okay, there are more than 30 seconds. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see what we got. Are you ready to see it? Ready, ready, ready? Let's see how did we do. Okay, mostly D. Better be correct, right? Okay, so here, what I'm gonna do is, okay, BI is already here. So I'm gonna draw BF from the tail of BI here. BF is going straight up. So that's that, right? So that means change is gonna start from tip of BI and gonna go to tip of BF. That's delta B. Okay. So yeah, radially inside. So it points towards the center of the circle. You see that? It points towards the center of the circle. Neither BI nor BF totally different. Okay. Okay, good job. So it points towards the center of the circle. So when something is moving in circular path, what's the direction of acceleration of that object? Do you know now or you don't? Let's check. Here is a question. And you have 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, are you ready? Ready, ready, ready? So mostly A, and that is correct answer. Towards the center. Just like this one was pointing towards the center, right? So if object is here, what's the direction of acceleration? This. What's the direction of acceleration? There, and so on. So that's how it works. Hey, see, interesting here. Acceleration is very different beast. Okay. So that's why we spend so much time learning about it, its direction. Okay. And we're going to be learning even more now using graph. So for now, until now, we use motion diagram, right? Until now, we used motion diagram. Now we're going to use a graph. So see this graph and motion diagram and so on. So those things are coming in second worksheet. See here, it says MD here means draw a motion diagram of whatever happening here. That's what it is saying. And then this delta V means change in velocity vector. So out of that motion diagram, pick two vectors and draw delta V using those two-step method. okay? And then there's going to be graph, which we're going to be talking soon. And there is a graph. So one has a velocity versus time graph. Another one has a acceleration versus time graph, okay? So two questions with two different kind of graph. One is velocity versus time. Another one is acceleration versus time graph, okay? So what are the things we already learned to complete this worksheet? We learn how to draw a motion diagram. We learn how to draw a change in velocity vector. Okay, so now we're going to be learning how to draw graph. Which graph? Velocity versus and acceleration versus time graph. Remember, position versus time graph we already learned. And that one also leads, the velocity versus time graph also leads to kinematic equation that we're going to be using to solve problem. So those are the kind of things we're going to be learning today. So I see there is a question on the chat. Why is acceleration on circle not somewhere between the two directions? So why not somewhere? So wherever it is, we learn how to draw it, right? we learn a method that tells us, how do we do it. So I think at this point, I'll just say that. But once we go to another chapter, dynamics, where we include force in the equation, probably it's going to be a bit easier to see that way, okay? So for now, let's keep that way, what direction it is and how to find it. So motion diagram, let's say if the object is moving in a particular direction and its speed is increasing, then the motion diagram looks like this, right? And let's say this velocity is, let's say somehow let's keep things simple, 3, 4, 5 meter per second, something like that. Then we can make a graph of velocity and time interval, velocity and time. So for first time interval, somewhere there, the velocity is this much. How much is that? Let's say that is 1. So you go here and put that. And the second, you have another velocity, 2, 3, 4, something like that, right? And you connect those lines and you have graph. So that's what I'm doing here in the PowerPoint as well, okay? So rather than writing number, I'm just writing B1, B2, and so on, okay? And then we draw a trend line. How do we draw a trend line? It's like drawing the average of the data. Even if some point were, let's say, off, you would draw something like that, okay? In between the points. Try to touch maximum number of points, but it doesn't have to be touching each and every point, okay? It's like going through the average of those, okay? In betweens. So anyway, so this is velocity versus time graph. So if we look at the change, or let's say rise in this case, we are looking at change in velocity. So that means slope gives us acceleration because slope is a rise over run. So in this case, rise is change in velocity. Let's say if I take these 2 points, that is the change in velocity. Velocity is in vertical direction. So any segment on the vertical direction is change in velocity. Any segment or the corresponding segment here gonna be change in time interval. And that's what we call run because it is in horizontal direction. Rise over run, so that's the slope. So what does this tells us? How do we find Acceleration from velocity versus time graph, just looking at the slope of that graph. And this graph, usually for us, it's not going to be carved like this. Velocity versus time graph is going to be straight lines. Okay. They could be going something like that or flat or could be coming down, but all of them going to be straight line, not carved line. Okay. So what that means, acceleration going to be constant. In kinematics, what happens is we talk about the things that has constant acceleration. That's what we do in kinematics. And this is the best, main chapter we are in. Okay. So we can write change in velocity as a final minus initial. We can do the same thing with the time. And we can rearrange this equation. So let's think about moving this one to the side of acceleration. So it is acceleration times this, right? And now this becomes something like this if I assume initial time is 0. So we can always decide to count time from the moment we start the observation, right? We can use a stopwatch and you start the stopwatch from 0. So we can always do that. So that way it's going to be just t, but although it's written t, it is actually time interval. Okay. It is actually time interval. Okay. So this is one of the kinematic equations, one of the three kinematic equation we're going to talk today. Okay. One of the three kinematic equations. So what it is doing? So this is the final speed, means what is final? Whatever time interval we decide to make measurements, the end of that time interval gonna be your final. Object could still be moving, but we don't care after that. Let's say if we decide to take observation until 5 seconds, then your final velocity is the velocity of that object at the end of that 5 seconds. Okay, so whatever the time interval is. So that's what I'm writing here. And this is initial velocity, means at the beginning of time, 0 time, I should say, at the beginning of observation. We said that was 0 time interval when we start our stopwatch, for example. Okay. And this is acceleration. And this is time interval, of course. And direction of acceleration is same as direction of change in velocity vector, or same as the slope. Direction of acceleration is same as the slope of the, remember, we need to pay attention, not the xt graph, not the position versus time graph. Slope of that would be velocity, but slope of velocity versus time graph, or BT graph, is the acceleration. So once you have velocity versus time graph, you can find the slope. Value of that slope is value of the acceleration, and sign of the slope is direction of the acceleration. So is this sloping positively or negatively, assuming these numbers are positive numbers? Okay. So it is positive, yes. Okay, it looks like there was a question here on the Zoom. Can you say the definition again? Definition of what? It's final velocity, I guess, right? Final velocity is the velocity we measure at the end of time interval that we decide to make measurements of, okay? So let's say we decide to make 5 seconds worth of, measurements. So at the end of 5 seconds, that's going to be final velocity. Okay. So from graph, how do you find value of acceleration and direction of acceleration? Just looking at the slope, or not looking at slope, but maybe I should say calculating the slope. Okay, calculating the slope. And remember, when you have line, I don't know if you can see me in the video, this pen is horizontal, means it has a 0 slope. Uphill has a positive slope, and downhill has a negative slope. So even without doing calculation, you can tell about whether the slope is positive or negative. Uphill, positive slope. Downhill, negative slope. Assuming that we are saying, okay, this up as a positive, okay? Up as a positive. So here is a question. So there is a velocity, there is time, and this side, this whole side is positive, and below the time axis, this whole thing that is negative. So that's what this sign means. So usually we don't write this, we may just write positive here. So that means you need to, you need to be you need to be able to tell, okay, down there, that's the negative side, okay? Even if I don't say it. Once we say see positive, other side of 0 gonna be negative, right? So here is a question. And answer, remember, graph is not highway. 30 more seconds. So velocity positive means right. That means velocity negative means left, right? So keep that in mind. Five more seconds. 5, 4, 3, 2, 1, and it stops. Oh, okay. Hey, are you ready? Let's see what we got. Ooh, this is challenging question. That's what tells me. Okay. Let's see what happened here. How do I go about it? See, the velocity data. So at 0 second, what we have, let's say, we don't need to put number, but we can see at 0 time, the value of velocity is maximum. As time increases, what happens? See, this is decreasing, isn't it? So this sign means direction for the vectors. So based on this graph, do we have any data that gives you positive number for the velocity? Are there any positive numbers from the data? We can see the line, you see the blue line? Do you think it's reading gonna be ever positive velocity? Yes or no? Can you type that? So this data does not have positive number, always negative because it's on the negative side. For this to be positive, it has to be on this side. It has to cross and go on that side. Okay. So that's why no positive means this object is not moving to the right, rather moving to the left. So all data negative, data means velocity here. All velocity negative means moving to left. So this thing is moving to left. This object is moving to left. That's what it means. Okay. Okay, so negative velocity means it's moving left. May not be towards zero. It may be away from zero anywhere. Okay. As long as it is moving to the left, velocity is negative. So I don't know what do you see as a left or right. The video may be inverted in terms of left and right when I show my hand. Okay. So is my hand moving right or left? So it is started from here and going that way. So my hand is moving towards the left. That's what you are saying. So what's the velocity of my hand? Left. Sorry, negative, let's say. As long as we assume right as a positive. Velocity is to the left. But once it goes there and turns around, then now it's moving to the right. So what's the direction of velocity? Right or positive based on this assumption. So that's how it works. Okay. So for example, if we assume north as a positive and you drive on I-25, you go no matter where you are driving, as long as you are driving to the I-25 north, your velocity has a positive sign. Okay. Once we say north is positive. And once you get up from that lane and goes to other lane to go to south, let's say, I guess you cannot change the lane in I-25, so you have to exit and get in. And once you start driving to the south, your velocity is negative. So that's how positive and negative works. Okay, folks? Okay, so that's that. So the car is moving to the right. Since it is moving to the left, anything that says right, moving to the right is incorrect. So these two are incorrect, I can tell just by looking at that, okay? So here it says left to right. So yes, it's moving to the left, but hasn't gone to the right. It's not reversing the direction. We don't know what happens after this because we don't have data, okay? So we cannot predict what's going to happen, okay? So that's why this is also not a good choice here. So now we are simply left with B or E. Now what's the difference? Constant velocity versus constant acceleration. Constant velocity means object is not accelerating or acceleration is zero. For that, slope of the line has to be zero. Which line? Velocity versus time graph line. Slope has to be zero. So do you think it has zero slope? When is the slope zero? When line is flat. horizontal to this time axis. It is not. So it has slope. Is the slope positive or negative? Is it uphill? See, this is positive. Up is positive. So is it going uphill or downhill? Okay. So slope is non-zero means acceleration is not zero, means velocity is not constant. So velocity is not constant. Okay. And in this case, it says acceleration is constant. It did not say positive or negative. So we don't have to worry about positive or negative. But even if it asked about whether its acceleration is positive or negative, you can tell by just looking at the slope, whether it's a positive or negative. Okay. So E is correct answer in this case. Oh, that was tough. So that's how you need to read and think and draw velocity versus time graph. Remember, in the next worksheet, you are drawing the velocity versus time graph. So, for example, here I'm giving you motion diagram, and I'm asking you to, uh, you know, pick a graph, or let's say draw a graph, choose a graph. So in the Zoom, I see a question. Does that mean the car is slowing down? Yeah, it is slowing down. It's getting towards zero. So that's why acceleration is in opposite direction. Hey, acceleration positive, velocity negative. They are in opposite direction, means it's slowing down. That's another way to look at it. So I think that question is about the previous slide. So now here is another question for you. And I'm opening the poll. After this, we're gonna take break, okay? So forget about this one for now. Thirty more seconds. Five more seconds. Five, four, three, two, one, and it stops. So basically this motion diagram, if I were to describe this in words, that's how I would describe. Object is moving to left and slowing down, right? Velocity is decreasing. So this side is left and velocity is decreasing. So which graph is that? So now we have a little bit more for B, but still there are quite a few confusion. So now it says left is positive and this thing is moving to the left. So that means velocity is positive. So that means these lines are not correct. Okay. So why did they draw a time going right to left? It's not time, it's the object. Remember, the object was here and then there. Object is free to move either left or right. Okay. So that means the answer would be either A or B. So now in this case, velocity is decreasing, right? So this is the largest. This is first, and then next, and next means velocity is decreasing. So it starts from the largest value, and then it decreases towards 0. If I look at A, it starts from a small value and gets bigger, and even bigger, right? So that's why B is the correct answer, just like many of you identified it correctly. So now, before we go, how about assuming left is negative this time? Here it was left is positive. Now left is negative. So what do you think? 30 seconds. Same motion, but you switch the coordinate, positive versus negative. Five more seconds. 5, 4, 3, 2, 1, and it stops. Let's see what we got here. Oh, it's still confusion, but mostly D. Velocity is still decreasing, isn't it? It starts from large value. So now it's being negative. They are not possible answer. But now what's happening? Velocity decreasing means it has to start from largest value and then go smaller and smaller. Okay. So I think C is correct answer. Oh, what happened? Many of you chose D. In case of D, what's happening? It's getting bigger and bigger and bigger. See, over here, it was just this much value. Over here, larger value. Over here, even larger value. Value is increasing. Okay. Negative sign simply means a direction. Okay. So that's why C is correct answer in this case, not D, because velocity is still decreasing no matter which way it's going, how we choose the coordinate. Okay, thank you, Salvador, for answering the question. So let's take a break. Oh, it's already 10. Oh, okay, let's take 5 minutes break, okay? Okay, folks, I'm back. Hopefully you are back too, okay? So we answered this question, oops, this question, but we haven't done this one. The worksheet, the second worksheet that's coming that I showed you, ask you to draw acceleration versus time graph as well. Okay, so position versus time graph, velocity versus time graph, and acceleration versus time graph. Okay, those are three main kinds of graph we use to describe motion. Okay, so now let's suppose you made velocity versus time graph. Now, can you make acceleration versus time graph? Right? So graph is here. So now let's say I want to draw acceleration versus time graph. Time is never negative, so that's why I do not want to draw on that side. Time is always positive, right? So we just draw on this side here. But this side, let's say positive acceleration, means this side is negative, okay? This side is negative. So now let's talk about A. So I want to draw a graph of this object. How do I describe motion of this object? If this is positive and let's say positive is right, let's say, or let's say positive is east. How do I describe this motion of this object? Okay, how do I describe the motion of object A? What do we know? It is, see, the velocity is positive means it is moving to the east. Positive means east. So it's moving to the east with increasing speed. See, the speed is increasing. And the rate of increase is constant. That means acceleration is constant here. So another way to say acceleration is rate of change of velocity. Rate of increase or decrease of velocity is acceleration. Okay? Whenever we divide something by time interval, we say that's the rate of change with respect to time, right? So acceleration being change in velocity over time. So this is rate of change of velocity. If the slope is constant, that means the acceleration is constant. So if I were to draw that acceleration graph, I mean that line on acceleration graph, acceleration versus time graph, constant means slope would be what? 0, means it would be flat line. Okay, it would be flat line. Now, will it go to the positive side or negative side? For A, slope is positive, it's uphill, right? And since we are choosing up as a positive, so uphill means positive slope or acceleration. So the line has to be flat, horizontal, and it has to be on positive side of the graph. So anywhere here is fine. So if I say this, so that means acceleration is larger. If I say this, acceleration is smaller than that. But both of these are positive. So if we don't know exact value, either one of these line is good, okay, for A. So this is acceleration for A. How about acceleration graph for B then? So slope comes from, sorry, the acceleration comes from slope. So you need to look at whether it's constant and whether it's positive or negative. That's all, okay? Is it uphill or downhill? Downhill means it's a negative slope. And it's a constant. See, straight line means constant. So that means B is going to be negative, okay? So I saw a question why on the chat, and I don't know in what context that why was asked, okay? So maybe you want to write a little bit more than why if you are asking, that way I understand the question, okay? So now for C, it's constant. Straight line means constant. And is slope positive or negative? For C, Slope is positive. Uphill means positive. Velocity is negative. It's moving to the left, but slope is positive. So acceleration is positive. So that's why it is slowing down. Positive slope. Downhill, negative slope. Okay. So there is a question. I get why the slope is flat, but how do I know where to graph the acceleration? And just like I said, it can be anywhere as long as you you are not given the value. Okay. Any one of these are just fine for A. Okay. Yeah, sometimes we need to learn how to deal without numbers. Okay. So I have another graph that has number, but here I don't have. And this is the kind of graph you get in the exam. Uh, no numbers. Okay. And we are learning to answer even without number. So D, faster away from zero. I don't know, away could be towards zero as well. As long as moving, see this zero is not position. This zero is velocity, zero. So as long as it is moving negative, sorry, I don't know, negative or positive. Which one did I? So here I said east. So that simply means it's negative means it's moving to west. Could be towards zero or away from zero. Because I think by zero you mean position. But remember, here this zero is not position because this is velocity versus time graph. Okay. So this is negative and slope is still constant. So this is going to be on this side. So D and which one is missing? I guess B is there, A, B, D. Where did the C go? Positive, slope positive and constant. So let's say this is C. So steeper the slope, higher the line you want to draw. Okay. Here hard to tell. So I'll just draw closer. How big is the acceleration? To find the value, we need to look at the steepness of the slope. Steeper it is, higher the value. Okay, so that's how we look at it. So now we learn about one kinematic equation. Which one was that? Vf Vi plus At. Okay, and we don't read it like that. Well, I'll talk about that later. So that is one. Now we're gonna get another kinematic equation from velocity versus time graph. But this time we're not going to be looking for acceleration. Rather, we are looking for displacement. How far object move. If you are given, let's say, velocity versus time graph, from there you can find how far or what's the displacement of the object. How do we do that? We know displacement is product of velocity and time. Here I am writing a bit loosely. I should be writing V average is displacement divided by, remember, this is the equation we know, and time interval. So if we use initial time 0, then we can just write that as a t as a time interval. So if I rearrange that, so displacement gonna be v times time interval. So that's what I'm writing here a bit loosely. So product of v and t gives us displacement, let's say. Okay, so that's what we know. So now when we make velocity versus time graph, what we have? Velocity in vertical axis, time in horizontal axis. Okay? Velocity in vertical axis and time in horizontal axis. So this is VT graph. Velocity time graph, right? So now let's go back all the way, sometimes in middle school, high school, elementary school, I don't know, when you learn about graph. So when we first learn about graph, what happens? We learn with this kind of graph. We have X and Y, okay? Horizontal X, vertical Y. That's what we have when we first learn about graph, okay? So when we have this, what happens is, let's say I have a line, something like this. So if I find the area under, this is going to be the area under. And what's the value of that area? You just multiply this y by x. So product of these two axes gives you area. Okay? Same idea. We get the same idea. We use the same idea. Here, what happens? We need a product of these two axes. See, the b axis and t axis. Just like we had y and x, and product means area. Similarly, we have b and time, and product means area. And product also means displacement. So that means displacement from velocity versus time graph is found by finding the area under that line or curve. Okay. So for example, I have this here. What is the displacement during first 4 seconds? So first 4 seconds means starting from 0 to 4 seconds, right? So up here, so I'm showing, with this dash line here. So that means to find displacement, we need to find this area. It's easier if we divide this into two parts, because we know how to find area of rectangle. It's just product of two side lengths, right? And area of triangle. Do we know how to find the area of triangle? Does that sound like something that we have learned? You have learned? Yeah. Half height times length. Yeah. Half base times altitude, something like that, right? So that's that. So that's why I'm breaking this whole thing into two parts, because I know how to find the area of rectangle and triangle. So once I have this area and this area, I can add them, and that's going to be total area that we are looking for. Okay. So area of this one is easy. This side length is time. This side length is velocity. So product BT is the area. So what's the total area then? So total area going to be, oh, I need to write somewhere here, looks like. BT, area of this portion, rectangle, and area of this triangle. Okay, area of this triangle. And area of triangle is half times base times altitude. And that's what I'm writing here in the second term, okay? Half base means time from here to here for this triangle, right? So this is the base of this triangle. And altitude or height means this, which is V for this triangle there, okay? That's the V. So that's T times V. And here I'm going to be using one more formula of the acceleration. See, this thing has this, it is accelerating. So can we introduce acceleration in this formula? And that's what we are doing, okay? See, this slope, non-zero slope of velocity versus time graph means acceleration. So this object is accelerating while going from 0 seconds to 2 seconds. It's accelerating. So can we include acceleration in this formula? So for that, I'm going to be using this definition of acceleration, delta V over time interval. Or I can replace V by A times time interval. Okay, so over here, I can replace this V by A times time interval loosely. So I'm not doing anything to the left side, but on the right side, what I did was I left this t alone and I replaced this v by a times t. So now what we have? T times a times t. Can I write that as a times t squared? So that is the second formula, kinematic equation. Okay, this is second kinematic equation. Okay, so here, even if you did not understand how we got it, you need to learn this and learn to use this, okay? And you also need to keep in mind that area under the velocity versus time graph is displacement. This one, this fact here, okay? Okay, so now we have two equations, but we write three equations. And what are those? So this is the kinematic equation, folks. Remember, in this class, three basic physics we learn: kinematics, dynamics, and conservation principles. So this is the kinematics, folks. So far, we learned about the variables involved in kinematic equation. Now we have kinematic equation. We saw, okay, this is just comes from the definition of acceleration, first equation. And second equation, we learned that it comes from the area under the velocity versus time graph, okay? So this is slope of velocity versus time graph. That came from slope of velocity versus time graph. This one came from area under the velocity versus time graph. Now, where is it coming from? Basically, it's the combination of these two. You see, these two have time in them, right? But this one doesn't have time. So what we do is we solve this one for t and then plug those t's here and simplify. When we do that, we get this equation. So I'm not going to do that algebra here. I may have done in note, or I may have said that in the note, but over here, just that's all, okay? So now, this is what I want to focus on. While reading this equation, remember our goal is to understand what this equation means and how to use this equation to solve problem. That's the goal. So if we read this equation something like BF is equal to BI plus AT, that may not make much sense. So that's why we do not want to read that equation like that. Rather, we want to read something like this, something like this. So whenever you see BF, you want to read that as a final velocity. Do not read that as a VF. Read that as a final velocity. But when you need to represent final velocity and you have numbers, then you want to say, okay, that is my final velocity. So that's the notation for final velocity. You do not want to read notation. Okay, you want to read actual meaning of that notation. And that's how I have written here. So for example, can you go ahead and read this one aloud? Okay, even if in your head, okay, even if it is on your head, okay, read it loud. While looking at this, read that and see if that you can follow it, makes sense. Did you read it? So this is how what I would do. I would look and say, okay, the displacement in a given direction. So we can use this equation in any direction as long as object is moving in that particular direction. Could be left, right, up, down. We can use those equations, these equation in any direction as long as object is moving, let's say either left or right, or east and west, up or down, okay? In all of those situations, we can write it. Although I have written x here, x is a particular direction here. Whatever direction the object is moving, we can say that is the x, and we can use that formula, okay? So that's why displacement in a given direction, in this case, I'm writing as a x, is equal to the initial velocity times the time interval. And by the way, initial velocity in that direction, same direction, okay, times time interval plus half times the acceleration, again in the same direction, times time interval is squared. So for time, we don't need direction because time is a scalar quantity. We don't have like 5 seconds. We don't write 5 second east, 3 second west, something like that. But for velocities and displacement, they have direction. So that's why I am emphasizing this direction thingy, okay, over here. So you want to practice reading these, something like that, okay? So now how to use those kinematic equations. So now you know kinematic equation, where did they come from, what they do? They simply relates these different vocabularies we learn about motion. Relationship between displacement, velocity, acceleration, time interval. That's what they are doing. How are they related? It's telling us the relationship between them. That's all, right? So now what we can do is we can use that relationship to find, let's say, one of those quantities, provided other quantities are given. So if we pay attention, all these three equations, they have 4 variables. See, 1, 2, 3, 4. 1, 2, 3, and 4. Time repeats there, right? 1, 2, 3, 4. All of them have 4. So out of 4, if we somehow know 3, then we should be able to find the 4th one. That could be any one of these. And which equation we choose depends on which one we know and which one we want to know. Which equation relates those quantities of interest. So for example, this equation does not have time in it. So if the question does not give you time, and if the question is not asking you to find time, maybe this is the equation you want to try, see if you can use it. So that's how you decide. And that's what I'm trying to tell you systematically here. So how do you do it? So for example, I am giving this example. This example is done in detail in the note. It's complete there. I just brought the part of it. So what you want to do is read the whole problem first and sketch the situation. So read at least once or twice or 3 times, doesn't matter. As long as you need to understand what's going on first. And then sketch the situation. So for example, here, what happens is, what is moving here? Remember, all this is about the emotion. So you need to focus. Okay, what object is moving here? So here, blood is moving. So we need where it starts and where it goes. Where is the end? Where is the initial position? Where is the final position? So that's what I am sketching. Okay. Where is initial? Heart. It starts from heart. That's what this problem says, and goes to the fingertip. So it's just keeping track of, we are keeping track of motion of blood that flows from heart to the tip of finger, let's say. Okay. And I'm assuming it flows in a straight line, although the motion may be slightly complicated. Okay. I'm just simplifying it here. So that's what this case of situation means. And you want to also assume which direction you want positive. You want to indicate that in this case. Which direction is positive? Okay. So once you have done that, what you do is reread the problem, now a sentence at a time. And while doing that, you want to write what is known, what is known, what is known with units with the proper variable. If you are asked to find distance or displacement, you want to denote that by delta x, not d or anything like that. Because our formula, you want to write everything in terms of the variable in the formula. And these formula are in the formula sheet, okay? Did you print the formula sheet? Okay. And by the way, in that formula sheet, in the previously posted formula sheet, I noticed there was this T over here, but I have already replaced this and I also sent you notification. So check in that formula sheet if it is T or X. It should have been X, not T, okay? Right now there is correct formula. It's corrected one, okay, page over there. So So why we want to list that? So that helps us to pick the correct equation. So there are three possible equations, which equation to use, right? So you look at it, okay, I know these three things, and I'm asked to find time. So I need to look for equation that relates these four things. So is there just one equation that has all four of these at one equation, in one equation or not? If there is, you got it. Now you can solve that problem just by using one equation. But sometimes you may not be that lucky. You may know two things from, one equation or the other, but you may not know all three of them in the same equation. Okay. So in that case, you may have to use two equations. You need to use two equations and solve those two equations. Solve something from one equation and plug that into another equation. Remember, in one of the algebra you worksheet, you solve for acceleration and you put that acceleration to find tension, something like that, right? It is like solving two equations, simultaneously. So that's the skill we're going to be using. And solving the kinematic equation going to be easier than those two equations we had in algebra sheet. It's going to be easier. So now, with that said, here is a question for you. Can you use just one equation? If you can, which one? If not, do you need to use two equations? So for that, what do you need to do? Read question, reread question. I mean, escape the situation and reread sentence by sentence and write down in terms of these variables, okay? And then you can pick the correct equation. So one thing I like to point out, sometimes I receive emails saying, hey, Ramesh, yeah, I know physics, but there is one problem. When I see a problem, read the problem, I get stuck. I don't know how to solve problem. This is the answer to that question, okay? This is how you need to go about, okay? So this slide is the answer of that question. Got it? So if you get stuck, come back to this slide, take a look, okay? Or look at this question solved in the note if you don't find the slide. The slide is also posted on Canvas, okay? Okay, so now it's time. So you have 2 minutes for this. Sketch the situation. You want to figure out where initial, where final is, and which way things are moving. Assign the sign for the symbols, positive or negative, and then write down things and see if you have all four things in one equation. 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see what we got here. Okay, so we have a bit confusion. Makes sense. This is very first question. So see, it starts from here. So this is, let's say, initial. This is final. So what is initial velocity? And it is just moving in both initial and final. They are in same direction. So it's going something like that. So that is like a displacement. And since it just keeps moving in same direction, that is displacement or distance. Same thing. Okay. Value is same as a distance because it's not changing direction. Okay. So basically we want displacement. And what is known? Initial velocity in that direction, the x direction is known. And let's say that direction, whatever direction it is moving from initial to final, let's say that is positive. So that gives me positive 8 meter per second. That is velocity, not acceleration. So it accelerates, it says, because velocity is changing. So that's why it is accelerating as well. Okay. But what is given is not acceleration. They are two velocities. Another way to look at it, meter per second is unit of velocity, not the acceleration. Acceleration has meter over second squared. Okay. And that helps too. Okay. So that is BIX. And how about BFX? 40. And its same direction means positive as well. And time interval, we don't need positive or negative for that. It is not a vector. So I'll just write that. Okay. And then it says calculate distance over which. So delta x is what? Do we have one equation that relates all four of these here? So this one does not even have a delta x, so no possibility. This one has a displacement, but this one requires acceleration, but we don't know acceleration. So we cannot just use this equation and solve for it. And same thing goes with this. Displacement is there, but acceleration we don't know. So we cannot use that one either. So best answer here is D in this case. Okay. So how do we solve this problem then? That means we need to use two equations. First, use this equation and find acceleration because see displacement, the equations that have displacement, they need acceleration. So we need an equation that we can use to find acceleration. And this one we can use to find acceleration because these three things gonna give us acceleration. Once we have acceleration, we can use either this equation or that equation and solve for displacement. So that's how we solve kinematics problem, folks. Oh, we are, 52. So there are two more slides. See if you can answer those questions. So we'll briefly go through those slides next class and gonna move forward from there. But still, we're gonna be in kinematic equation and how to solve it. We're gonna be reviewing that again and again, okay? Make sure and go look at this fully solved question and try solving it without looking at it as well. After you think I knew it, just read question and see if you can solve it. Okay. So you need practice. Without practice, you cannot be a good problem solver. Okay, folks. Okay, I'll let you go. If you have quick question, stay behind and ask me, or else you can go. I'll see you next class.